So the next topic we are going to start, that is the gas liquid chromatography. Okay, so let's start. The gas liquid chromatography. The gas liquid chromatography, that is also called as the GLC. Okay, so gas liquid chromatography. सबसे पहली चीज, the first thing you should keep in mind that gas liquid chromatography, the mobile phase and stationary phase. The mobile phase up here, that is some gas, and the liquid phase up, stationary phase up here, that is the liquid. Okay, so you got the mobile phase, which is a gas. You got the stationary phase, which is the liquid. Okay. How does the gas liquid chromatography it work, and how do we do the calculation of the GLC? Okay. So first of all, my dear, for the gas liquid chromatography, you people use a very thin and long tube like that. Okay. So this is a very lengthy and very long tube. It's almost 2 meter long. इसकी लेंथ जो है that is 2 meter. 2 meter long, and the second thing, my dear, it has a diameter of almost 2 millimeter. 2 millimeter. Okay, so 2 millimeter, that is the diameter. Okay, and it's 2 meter long. Now, what would happen, guys? If you take gas liquid chromatography, so this is a very long tube. So this long tube will occupy a large amount of the space. So what we do, this is a glass tube. If you heat the glass, it will become very soft and you can mold it in any way. So the first thing, what should you do? You should take this 2 meter long glass tube, okay, with a diameter of 2 millimeter. So you should heat it well and make it in a in this shape, in a circular shape like that. Okay, so that it can occupy less space. You can coil it like that. Okay. Did you get it? Now, we started with the gas liquid chromatography, GLC. The mobile phase up here, that is gas. The stationary phase, that is the liquid. For the gas liquid chromatography, we use a long tube, almost 2 meter long glass tube, and with a diameter of 2 millimeter. Okay, so because 2 meter, that is the large length. Okay, so it occupies a large space. So that is why what we do, we just heat this glass tube and mold it into a circular way. Okay, to reduce its space. Okay, did you get it? Now on one end of this glass tube, what should we do? To join it with a auto seal rubber. So this is the auto seal rubber on its one side. Okay, and this long glass tube, it has got a liquid inside it. So this liquid, that is the non-volatile oil impregnated with silicon dioxide. What does it mean? A non-volatile oil. Non-volatile oil, you know that the mobile oil, okay, it's normally non-volatile. It has a high temperature, okay, to change into the gaseous state. So that is the non-volatile oil. which does not evaporate very soon. It has got a very high boiling point, sorry. And what you did, you have taken the non-volatile oil and mixed silicon dioxide. Silicon dioxide is a sand. You mix little bit amount of the sand inside it. Okay. So this is non-volatile oil. So this is actually the stationary phase up here. This is the stationary phase. Okay. And it is present within that tube. Okay. Now this is the auto seal rubber. This auto seal rubber, my dear, that is joined with a delivery of a gas which has got a tap up here like that. So this is the tap. Okay, my dear students, now what we are going to do, this is a gas cylinder in which some inert gas that is present. The inert gas normally we use up here, that is mostly nitrogen, or the second thing, that is the argon. Why nitrogen that is taken as the inert gas? Because nitrogen, my dear, it got the triple bond between the two nitrogen atoms. Okay, so you require a large amount of heat energy to break this triple covalent bond, so which does not break up very easily. So that is why normally it's inert. Okay, whatever uh, shops, you people are going to buy some chips or something like that in the packets. Okay, so the air that is present inside it, that air part contains the nitrogen, because nitrogen is unreactive. Okay, so that is why the chips or whatever the minos or whatever the things which are present inside that wrap, okay, that would remain safe. They won't react. Okay, my dear, so nitrogen and argon, normally they are used as inert gas up here. Okay, so this is a tap, this is a valve which is closed. Okay, now on the other side of this tube, okay, this one is joined with a detector. This is the detector, and this detector, my dear, that is joined with a recorder. So this is the recorder. So what the things are recorded, what the detector detect, I'm going to tell you. Okay. This whole system of the tube in which the liquid is present, okay, you should keep it in the oven. This whole thing is present in the oven. Okay, like that. So this is the oven. And please remember the temperature of the oven that is maintained at a particular point where any liquid which guys, just listen, any liquid thing which enters inside that glass tube, okay, up here, so that would change into vapors. No liquid can enter inside that glass tube from here. Okay. As soon as the liquid would enter, the temperature is maintained so that the liquid thing that would evaporate and form the vapors. Okay. So here the temperature is maintained at which any liquid enters would change into vapors. Okay. Okay, my dear, now you have to listen it very carefully that how this gas liquid chromatography that is going to work. That is very important. The first thing before starting the experiment, you should open up the tap. Okay. So this tap will pass from here, would enter up here, would go up here. This is a non-volatile oil. Non-volatile oil that is actually, you know that non-polar. It's a long chain of carbon and hydrogen. Okay, it's non-polar. So non-polar thing dissolve the non-polar things more inside it. Okay, whereas the non-polar thing dissolves less the polar thing. Okay, so the gases, they are non-polar. Okay, so they would pass from this liquid. Okay, and when they are going to enter in the detector is going to tell us the retention time. Retention time means, let's suppose the gas travel from here at 120 and it reaches up here, let's suppose at 120.25. Okay, in 25 seconds, let's suppose. Okay, so it means that will tell you the retention time, and what would happen? It will draw a graph like that. Okay, where you got the retention time, and here we got the absorbance. Okay, so the first peak formed, that is called as the solvent peak, like that. So this is called as the solvent peak. Did you get it? And this solvent peak is actually of the gases peak. Okay, so how much retention time these gases have inside that non-volatile oil? Non-volatile oil stop these inert gases for how long? Okay, so this one is going to record that retention time, and the recorder is going to record it in the form of this graph. Okay, so the first peak form, that is the solvent peak. Did you get it? Now let's suppose, my dear, you people are the analysts. You people are the food inspectors. Okay, so you have gone into a juice factory. Okay, and you ask, and you ask the owner of the juice factory that which ingredients you are going to use in your juice factory. He's going to say, I'm going to use 4 ingredients. So you people are going to ask him that what are the name of the ingredient and what is their percentage. Just write it. He's going to write it. Then what you do, you take the sample of the juice into a syringe, into a plastic syringe. Okay, now that plastic syringe has got the needle. So what you do, you do the gas liquid chromatography. So with the help of that needle, you are going to introduce the liquid. So this is the piston. So here we got the liquid or juice up here, let's suppose. Okay, and this is the piston, let's suppose. Okay, so you are going to press the piston, the liquid drop will enter up here, the gas is already flowing. Okay, you did not close the tap of this gas. The gas is already flowing. So you enter a little bit amount of the juice inside that auto seal rubber. You take out the gas, you take out this needle. Okay, so this is a special rubber, my dear, which seal itself automatically. So that nothing is going to leak through it. Okay, so that is called as the auto seal rubber. Now, what's up? You get the idea? Okay, so that gas is going to take these liquid thing inside the glass tube in the oven. So what does the oven do? Oven is going to, come on, change it into vapors because you have maintained the temperature at which the liquid droplets will change into vapors. Okay, so vapors, they are of different kind because the juice has got different ingredients. So their forces of attraction with these non-volatile oil, that is different. Okay, so if it has got the non-polar part, it will stay long. And if it has got the polar part, polar things, they dissolve in the non-polar thing, not too much. Okay, they will stay less. Okay, so if anything new would enter into the detector, detector is going to make a peak like that. So different peaks, my dear students, they are being formed. Okay, so I have got not enough space up here. Let's suppose if 5 peaks are formed, let's suppose, and that person has said you, I have got 4 ingredients in my juice. So 5 peaks means that there is some impurity present inside it. Okay, did you get it? Yes. So the number of peaks will tell you that how much ingredients are present, and if you want to calculate the percentage, so what should you do? You should take a scale by your own. Okay, so this is the triangle. Make the triangle of it, cut it into 2 equal parts like that. So these are the 2 right-angled triangles. So find out their area by half length into breadth, and find out half length into breadth, and then add it up. Let's suppose its area is 80, its area is, let's suppose, 30, and this is the A peak, this is the B peak. You find out the area by using these formulas. If you got any good idea of finding the area of that triangle, you can find it out. I'm not a mathematician, so what I did, I divide this whole thing into two right angle triangles, find the area by this one, half length into breadth, and then half length into breadth, and then add it up. So it will give you the area of that. Use the scale. Okay. So this length and this width, this length and this width. Okay. Did you get it, Muskan and Yaya?
Yes, sir.
Yes.
Okay, now guys, if you want to find out the percentage, so A, so if you want to find out the percentage of A, so what should you do? Uh, the thing up here, that is 30, the total thing 30 plus 80 and times 100. So whatever the total triangles present, I have just drawn the two triangles. So if you got five triangles, so you should take the areas of the five triangles in the denominator, added them into 100. So that will give you the percentage of A in the juice. If you want to write this whole story in your own word, you can write it. Okay? Because I have explained every bit of thing for you. Okay? So if you want to write it in your own words so that it will remain in your mind, you can do it. And then I'm going to open some questions in front of you, and we are going to discuss those questions with respect to GLC. Okay?